Let's look at number 3. TRI, negative 4, 0, negative 8, negative 6. These is TRI, 0, negative 6. There's my original figure. And if you take a look at this one, that means it's triple prime. That means there are 3 transformations. I'm going to abbreviate and not finish. All right, so T triple prime is 0, 2. R triple prime is 3, negative 4. And my I triple prime is 3, 0. Oh, I went wrong direction. 3, 4 is not down there. It is up 3, 4. I was like, that didn't look right. And 3, 0. And then, so T triple prime, R triple prime. So there's a lot going on in this one. All right, triple prime. Automatically, I can tell the triangles are not the same size. If I take a look at my RI is how many boxes? 1, 2, 3, 4, 5, 6, 7, 8 boxes. All right, so there's 8 boxes in between this RI, and there's 4 boxes between this RI. So automatically, one transformation that is done, it is dilated. Or the scale factor. So we started off, okay, the scale factor, okay. I forgot what numbers I said. This is 8. Yep, 8, and this is 4. So when it goes from 8 to 4, the scale factor is 4. So it's getting smaller. 4 divided by 8, which is 1/2. So that's what's going on. So each of these numbers have to be multiplied by 1/2 to get my first transformation. So we have negative 2, 0. Negative 4, negative 3. And the last one is 0, negative 3. So negative 2 zeros there. There's T prime. R prime is negative 4, negative 3. And I prime is 0, 3, negative 3. All right, so now we got our triangle the same size. Then I take a look at the order. All right, so in this one, the T starts off on top, and our next figure, the T triple prime's on the left. So when you think about it, when you are facing up and then you are facing left, you are turning, or not up, forward, facing forward, then facing left, you are turning 90 degrees. Now, how many degrees are we turning it? 90 degrees clockwise? Up. When you face forward and turn left, you are going counterclockwise. So for the next one, it's going to be rotated 90 degrees clockwise. No, counterclockwise. So remember, when I rotate something, you switch the order of the x and the y. So my t double prime is going to be 0, 2. My r double prime is going to be 3, 4. And then depending on what quadrant is going into, it's going into the second quadrant. So I'll adjust my signs afterwards. 3, 0. So everything, that means it's going to be in this quadrant. So everything in our second quadrant is negative x, positive y. So you can't take negative 0, obviously, but you can have a negative 3, positive 4, negative 3, 0. All right, so we have 0, 2. In which I didn't really want to turn it this way, but it's okay that we ended up turning this way. 0, 2, which is my t double prime, r, which is negative 3, 4. That's my r double prime. My I double prime is 0, negative 3. So now I have my figure. Now I didn't really rotate it in the order I wanted it to, but that wasn't necessarily a bad thing. As long as we rotated it 90 degrees, it ended up being a figure that we can do one more transformation to in order to get our triple prime. So in order to get our triple prime, we take a look, and it looks like a mirror image of the other. The purple triangle is a mirror image of the red triangle. And so we are reflecting it over the, what color am I going to use? Let's use pink. I'm going to reflect it over the y-axis. That's the y-axis. So my r double prime and my r triple prime, they're both being reflected over the y-axis. When I reflect something over the y-axis, that means my triple prime. That means you're basically just taking, I don't even have to write each point, you're taking the x values and changing the signs. So my t triple prime, and we're going to see if it matches up, is still 0, 2. My r triple prime is positive 3, 4, which matches up here. And my I prime, triple prime is positive 3, 0, which matches up here. So those are my three transformations. It's dilated with a scale factor of 1/2. Oh, I want to do it in black here. Dilated with scale factor of 1/2. It's rotated 90 degrees. Then it's reflected over the y-axis. Now, are these congruent or similar? Now, remember, a similar figure is the same shape but a different size. And since we are dilated, that means these figures are similar, not congruent. All right, so work through these problems. It takes a lot, sometimes it takes a couple tries to figure out what kind of transformations are being done to the figures. But if you always start off with see if it's dilated first, okay, then take a look at order of the points. So if you look at the order of the points, it's either rotated 90 degrees or rotated 180 degrees. So you take a look at that and then see if you could reflect it or translate it. Okay, you just go through the proper steps. You'll be able to figure out what the transformations are as you practice more with these problems. All right, so that's it for today's video. If you have questions in class, let me know.